All right, second last, well, yeah, second last video. So second last video, again, we're going to be looking at another transformation. So this time we're going to be looking at a. So we're building all the way up until we have a times x minus h all squared plus k. So this is our last transformation to look at. Let's start with our base parabola. So we know with a base parabola, y is equal to whatever x is squared. So 0 squared is 0. Negative 1 squared is 1. Negative 2 squared is 4. Negative 3 squared is 9. Negative 4 squared is 16. Same thing on the other side. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. We know that our base parabola has a vertex at 0, 0. The axis of symmetry would be x equals 0, and there are no transformations. So let's just sketch that on my grid. So we're going to start at 0, 0, over 1, up 1, over 2, up 4, over 3, up 9. Same thing on the other side. Or you're just plotting those points that you just found. Okay, now we're going to look at the effect of A. Now, I will say, first off, that the A is not in the bracket with the X. So this is going to be a transformation on Y. It's going to do something to the Y values. Let's start at this vertex 0, 0. When I plug in X is 0, 0 squared is 0, and then 2 times 0 is 0. So 2 times 0 squared gives me 0. When I put in negative 1, I've got 2 times negative 1 squared, which gives me 2 times 1 is 2. When I put in negative 2, I've got 2 times negative 2 squared. So this is 4 times 2 is 8. When I put in negative 3, I've got 2 times 9, which is going to give me, I'm having a brain fart, 18. When I put in negative 4, I've got 2 times negative 4 squared. So I've got 2 times 16, which is 32. What happened? Oh, look at the y values. It was 1, now it's 2. It was 4, now it's 8. It was 9, now it's 18. It was 16, now it's 32. All the y values were multiplied by 2. And since I know the thing about symmetry, I know that these ones will go 2, 8, 18, and 32 as well. So even if it's a positive number in here, squared, it gives you the same thing. So what happened? Did it change the vertex? Nope. Still 0, 0. Did it change the axis of symmetry? Nope. So what did it change? Well, let's sketch it. So we had a point at 0, 0. Then we had a point at 1, 2. Then we had a point at 2, 8. If we connect the dots, because that's all it's going to fit on my grid, what is happening? Well, let's do it the other way. Over 1, up 2, over 2, up 8. Now, in Math 60, what we're going to say is that this is a vertical stretch by a factor of 2. All my y values got stretched by 2. In Math 50, the wording they use is that the graph got narrower. I don't love that, but sometimes I don't want to fight the textbook because the textbook is a really great resource for us. So the textbook likes to say that the graph got narrower, but it's because there was this vertical stretch by 2. All the y values were multiplied by 2. Now, let's make a generalization for this. Let's put into Desmos. Let me just open that up. All right, so we've got our y equals x squared. Let's put in that 2. It's that vertical stretch by 2. All the y values were multiplied by 2. Instead of this point here at 1, where is it? There's 1, 1, right? 1, 1. Oh, so hard to find a point, Desmos. Might have to stop. Ah, good. 1, 1 got stretched up here to 1, 2, right? They were all multiplied by 2. Oh, that's a fruitless effort. I could actually just add in tables of values if we liked them instead, right? So you can see here all the y values were multiplied by 2. If I want to put in a 3, what do you think is going to happen? Well, we're going to multiply all the y values by 3, and so the graph's going to get even narrower. Instead of going over 1 and up 1, we're going over 1 and up 3. Instead of going over 2 and up 4, we're going over 2 and up 12, 4 times 3. So this blue graph is even narrower than the green graph because it got vertically stretched more. If I was to put in another one, So if I was to put in like a 4, it's going to stretch it by a factor of 4. It got even narrower. If I looked at the table of values, it goes over 1 and up 4, right? 1 times 1 is 4. Instead of over 2 and up 4, it goes over 2 and up 4 times 4, so it goes up 16. It's getting narrower and narrower. It's getting more and more vertically stretched. So going back to our note, okay, the value of A, when that A value is greater than 1, you get this vertical stretch and your graph gets narrower. Okay, let's look at see what happens when we put in an A value like a half. What do you think is going to happen? What color haven't we used yet? Let's use, yeah, sure, purple. Okay, so now we're going to put in -4. So this is going to be y equals 1/2. Actually, let's start the vertex. I like starting the vertex. So we've got y equals 1/2 times 0 squared. Oh, look, it didn't change. It's still 0, 0. This still has a vertex of 0, 0, x equals 0. Okay, what's going to happen from there? Well, let's go positive this time. We're going to go 1/2 times 1 squared. Well, half of 1 is still a half, or 0.5. Some people like decimals better than fractions, and that's totally fine. When we go over 2, the square of 2 is 4, but then I have to go half of it. So, oops, I wrote I wrote 4 as I said, or as I said it. So 2 squared is 4. Half of 4 is 2. Then we're going to go 3. Half of 3 squared is half of 9, which is 9 halves, or 4.5. Then we put in 4. Half of 4 squared is half of 16, which is 8. Let's just sketch that side. So we're going to put 0, 0. Then I'm going to go over 1 and half as high of 1. I'm going to go over 2 and half as high of 4. So I'm going to go up 2. I'm going to go over 3 and half of 9, which is 4.5. And then I'm going to go over 4 and up half of 16 to 8. So what has this done to my graph? Well, let's look on the other side. Is anything going to change on the other side? Nope, because all these values squared are still going to come out positive. So it's going to go 0.5, right, 2, 4.5, half as high, and then 8, right? So on the other side, we're still doing the same thing. Over 1, up a half, over 2 and up 2, over 3 and up 4.5, and then over 4 and up 8. We would call this a vertical, now here's again, Math 60, our textbook calls it a vertical shrink. So instead of a vertical stretch, it's being shrunk in the y values. I like the word compressed. I can picture it compressing on the y-axis, right? It's getting closer and closer to 0. But our graph's going to say that it got wider. Now, can we make that generalization? Well, let's check in Desmos. If I go and I change all of these a values to fractions. So instead of 2, I'm going to put in 1/2, right? Well, let's take all these other ones off. That's confusing. Okay, so we've got our red graph being our base graph, right? Then we've got the green graph, which has been compressed vertically by a half, which made the graph wider. If you look at the table of values, instead of going 0, 1, 4, it goes, oh, that's the wrong table of values. Sorry, I thought they would adapt. Okay, so if I was to put the table of values for this guy in here, right? So instead of going 0, 1, 4, it goes 0, a half, and 2. It's going half as high. If I was to put in a third instead of 3, what's going to happen? Well, it's going to get even wider. If I looked at the table of values, it's not going to be a very nice one, right? So instead of over 1, up 1, it's over 1 and up a third. Instead of over 2 and up 4, it's over 2 and up 4/3, right? Or 1.3. And then the quarter looks a little bit better. Let's just put that in here. 1/4. And then I can put in that table of values as well. But let's see what happens. Quarter, look, it's even wider. right? And if you look at it, instead of going over 1 and up 1, I go up over 1 and up a quarter. Instead of over 2 and up 4, I go over 2 and up 1. So my graph got compressed vertically, which made the graph get wider. So let's put that in general. When that a value is between 0 and 1, so it's this fraction less than 1, the graph got wider. Did the value of a affect the location at all of the vertex? Nope, because anything multiplied by 0 just keeps it 0. So it's still 0, 0, which means the axis of symmetry is still x is equal to 0. Awesome. Now there's a second part to this video. We have just looked at these a values that are positive. We put in a positive 2, we put in a positive a half. What if we made the a value negative? What would happen to our graph? Well, let's start off with a table of values. Our base negative graph would be y equals negative x squared. Let's start at the vertex. We've got y equals negative. It's the 0 being squared, which would give us negative 0, which is just 0. Then let's put in 1. I've got negative 1 squared. Now what's really important is only the 1 is being squared. So you're squaring and then timesing by negative 1. So it's going to make it negative 1. If I put in negative 1, I'd have negative 1 squared. But again, you have to square before you multiply. So negative 1 squared is positive 1 times negative 1 is negative 1. If I put in 2, I've got negative 2 squared, which is going to give me negative 4. And even if I do negative 2 squared, I still get negative 4. So thinking about the pattern, over 1 up 1, over 1 up, or over 2 up 4, over 3 up 9, instead of going up, we're going to go down. Instead of going over 4 and up 16, we're going to go down 16. And we're going to have this pattern on either side. And if you don't trust it, feel free to just keep putting in those values for x. But let's graph it. We've got a vertex at 0, 0 for this graph. Axis of symmetry is x is equal to 0 because the a value doesn't affect the vertex or the axis of symmetry. But this graph is going to go over 1, down 1, over 2, down 4, over 3, down 9. So what did this a value of negative 1 do to my graph? Well, it made it open down. So I've already decided the a value does not affect the vertex, but we'll say that it opens down, right? Or the graph has a maximum instead of a minimum. All right, let's look to see what happens if we throw a 2 in there as well. So if we've got y equals negative 2x squared, what do you think is going to happen? Well, let's start with 0. Negative 2 times 0 squared is still 0. If I plug in 1, 1 squared is 1 times negative 2 is negative 2. If I plug in 2, 2 squared is 4. 4 times negative 2 is negative 8. If I plug in 3, 3 squared is 9. 9 times negative 2 is negative 18. My y values are being stretched by 2 and opening down. So instead of 0, 1, 4, 9, I've got 0, negative 2, negative 8, negative 18. That would make this negative 32. And would anything change on the other side? Nope, right? Same pattern. And if you don't trust it, check a point. So let's plug in something like negative 3. So negative 2 times negative 3 squared. Negative 3 squared is 9. 9 times negative 2 is negative 18. So the vertex is still at 0, 0. Axis of symmetry is x equals equal to 0. And this graph is going to open down, and it's going to be narrower. Let's check it. So if I plot these points, I've got 0, 0. I've got over 1 and down to negative 2. I've got over 2 and down to negative 8, and that's all that's going to fit on my grid. So this graph is opening down, and it's even narrower. Okay, can you guess what this last one's going to do? Is it going to be any different than y equals 1/2 x squared? Well, yeah, it's just going to open down. So if we think about it, we have a vertex at 0, 0, right? Negative 1/2 times 0 squared is still 0. And then if we put in 1, we've got negative 1/2 times 1 squared. is still negative 0.5. If I go negative 1/2 times 2 squared is 4. Half of 4 is 2 times negative 1 is negative 2. I'm taking my y values and I'm dividing them by 2. So this one's going to be negative 4.5 and this one's going to be negative 8. It's really hard to tell on a video. Like, I don't know if you guys are good. You know, in a class, I'd be like, do you guys have it? And then we could just like copy them in. But I don't know how many of you still need me to do the whole table of values. So let's go the other way. This one's going to be negative 0.5. Again, we're taking this y value and we're timesing it by a half. We're taking this y value, we're timesing it by a half. So your base parabolic shape, and you're taking half and negative 1. Okay, let's check one. So let's go negative 1/2 times negative 4 squared. Oops, that looks like a 9. Negative 4 squared is 16. Half of 16 is 8 times negative 1 would be negative 8. So if I was to sketch this, I'm going to start with a vertex of 0, 0 again, which means the axis of symmetry is equal to 0. And I'm going to go over 1, and instead of going down 1, I'm going to go half the distance. Instead of going over 2 and down 4, I'm going to go half the distance. Instead of going over 3 and down 9, I'm going to go down negative 4.5. Instead of going over 4 and down 16, I'm going to go down 8. So I'm plotting more points, but there's still only 5 nice points. And then on the other way, I'm going half, I'm going half, or you're just taking these points and you're mirroring them over that axis of symmetry, and then you're connecting the dots. So how would you describe this transformation? Well, you'd say that it was opened down because of that negative a value, and that it's wider because of the half. So describe how the value of a transforms the graph. When a is less than 0, it makes the graph open down. In Math 60, we'll call this a reflection of the y values, because the y values are being made negative over the x-axis. But for us, we can just say, hey, the graph opens down. And then that still stands. If the a value is greater than 1, right? So the absolute value of a is greater than 1, then it's going to be narrower. And when that a value is between 0 and 1, the absolute value of it, it's going to be wider. And when I say absolute value, right, I'm saying that negative 2 is not greater than 1, but 2, right, without the negative is greater than 1. So I still get that narrowing of the graph. Awesome. Okay, that is your next page of practice.